right, welcome back, team. We're now looking at section 1.6, absolute value functions. To help with absolute values, we need to understand what it represents. The absolute value of x represents the distance from 0. Okay. So you can think at it as the distance on a number line from 0. And remember, distance is never negative. That's why the absolute value is always positive, because it represents distance. If you have the absolute value of, let's say, x minus a, then that's representing the distance from a. So let's consider the example below where we want to list two numbers that are 3 units away from 0. Well, here's our 0 here in the middle. Well, we know the number 3 over here to the right is exactly 3 units away from 0. But there's also another number that is 3 units away from the 0 on the left, and that is -3. Funky looking brace there. So that's why if we were to take the absolute value of 3, we would get 3 because it's 3 units from 0. Likewise, the absolute value of -3 also gives us 3. So let's consider the absolute value of x equals 5. Now we know that the number inside that absolute value either represents 5 or -5, okay? So one way of looking at that is that the inside number equals 5, or that inside number, the opposite of that number, equals 5. In other words, it's representing the positive version or the negative version. So when solving absolute value equations or inequalities, I'm going to show you a way that works for both. We have two possibilities. So remembering that an absolute value on the inside could be a positive version or a negative version helps you to remember that you're looking for two possible solutions and also how to look for those solutions. Okay, so let's take a look at this example here. We're going to look at it algebraically first. So we want to solve the absolute value of x minus 4, that quantity being greater than 2. Well, our first option is that the inside is the positive version. So we can think of it as distributing a +1 to the inside, and that being greater than 2. And when we solve for that, we distribute the positive, nothing changes on the left. We can add 4 to both sides, which doesn't change our inequality, and we get x is greater than 6. Great. But the second possibility is that absolute value is representing the negative, the opposite. So we're going to distribute a -1. So if we do a -1 times the entire inside of the absolute value, that will give us the opposite of x plus 4 is greater than 2. We're going to subtract 4 from both sides, so we get the opposite of x is greater than -2. And remember, when you divide by a negative number, and we'll write that little note here, when we multiply or divide by a negative, switch the inequality. Okay, so don't forget that old rule. It still goes into play, even though we may have learned it in 5th grade. It's still true today, okay? So if we divide both sides by the -1, we get a positive x less than 2. So if we're looking at it in terms of the number line, We know that we need our x larger than 6. So let's see, 6, we're going to have to extend this a little bit. So we need our x larger than 6 and an x smaller than 2, all the way out here. Now, when we look at the original equation, this means the distance from 4 is larger than 2, right? Absolute value represents distance, so the distance from x to 4 has to be larger than 2. Well, if this is our 4 right here in the middle, there's 2, so it has to be larger than 2. Over here on the left, that 2 is 2 distance away. So we're going away from the number 4. So we end up with 2 intervals as our solution. So the left interval, we're going from -infinity to 2, union, and then we pick it back up from 6 to infinity. Remember, since our inequality is strictly greater than, there's no or equals to, then nothing's included. Everything is in parentheses.